Okay, today we are on circles. We're doing, 5.2. And our warm up is to find the circumference of the circles. So if you don't remember circumference formulas, you can go to our notes in Google Classroom. Bunch of circle stuff. We did some of this yesterday. Area, circumference is here, then some more information about arcs and scrolling, more arcs, formulas. You're going to want to look at these. You'll need them in the next couple weeks. Inscribed angles we talked about in yesterday's warm-up, but there's more to those. So circumference is where we're at. There's two ways we can go about it. The diameter times pi, or 2 times pi times the radius, which of course makes sense because two of the radii, I think both is correct. Two of the radii is one diameter, so that makes good sense. So we can use either one of those depending on what we're working with. In the first one, they give us the radius. So we're going to do 2 pi r. That'll give us the circumference. So the circumference is 2 pi r. I'll do that, just emphasize those being multiplied. That pen isn't great. Let your calculator do the work. Very often, my calculator doesn't want to do the work. Very often, we'll want to leave it in terms of pi. So 2 times 2.3 is 4.6. So that's an exact answer, but I believe Apex is going to ask for the estimate. So I'm typing that in my calculator. Oops. Times 4.6. There we go. And that will give us a circumference of 14.45. And again, I think Apex is going to say, what is the circumference about? And so they might give an answer of 14. Probably they'll give an answer of 14. Okay? The next one gives us the diameter. The diameter is 10. So it wouldn't make sense to figure out the radius, which of course is 5, and then use 2 pi r. Instead, we could just do the diameter times pi. And right away, we have the exact answer. And then it shouldn't be too hard because it's 10, but we type it in. It's about moving the decimal, 31.416. But again, Apex is going to probably round to the whole number. So they'll say about 31 units. Okay, so that's our warm-up. Let's switch to the worksheet. The first two are not something I'm going to do because that is something you can do. I will start with number 4, which isn't too terribly difficult. The segment shown is a radius of circle A, 11.3. What is the length of the diameter of the circle? Well, we kind of just talked about it, I guess. The diameter is 2 times, I'm right with that setting. Let's get the right tool. The diameter is 2 times the radius. So the diameter is 2 times 11.3. And if you want to put it in your calculator to make it a little bit easier, that's fine. Diameter is 22.6 units. They don't tell us what. So diameter is just twice. Oops, you can't see anything I'm writing. Diameter is just 2 times the radius. Sorry about that. Couldn't see what I was doing. All right, I'm going to let you do the rest of that page. Seriously, this is almost elementary work. It does pick it up. It becomes significantly more difficult. I mean, we have to know our high school level stuff at this point. So let me zoom out so you can see what I'm writing. If the dotted line segment is a radius, so from A to this point on the circle is the radius, CB, this chord here, is perpendicular to AD, and they show that with the symbol. It's definitely perpendicular. And if CD is 3, they show that in the diagram. What is the length of the chord all the way from C to B? Well, one of the rules says that if you have a radius perpendicular to a chord, then these segments that are split are bisected, meaning they are equal. So if CD is 3, that must mean DB is 3, which means the segment of the chord is 3 times 2, or 6. So that's just a rule you have to know, kind of stepping it up to high school level. And number 7 is just like that. But the key is they have to be perpendicular for that to be true. Okay, so there's another to practice. That's on our quiz. What's the length of CD? I think I'm going to do this in pencil because I might want to erase it. I'm going to kind of prove it to you. CD is a chord, and we have another chord, BE. Let's just focus over here on this zone real quick. I could draw in a radius, right? From the center to any point on the circle is a radius. And I could also draw a radius over here. They're both a radius. And we learned, let's see, what did we learn? We learned that if this line segment here is perpendicular to the chord, it splits it in half. So this is like 4.5 right here, and this one's also 4.5. You won't need to do all this work I'm going to do right now because, after I've proven it, because, shoot, now I'm thinking, how am I going to prove this? Hold on, I'm thinking it through. I had a thought on similar triangles, but they don't give me the radius exactly, so I'm not going to be able to prove it the way I wanted to. Okay, well, then I'm just going to have to tell you the rule. Sorry, I had a plan to prove the rule. I'm sure there is a way, and it's just not coming to me right at this minute. So, scratch that. Good thing I used pencil. Here's the rule. Let's just dive into the rule. The rule is this. If you have two chords that are both perpendicular, they're segments that are perpendicular to the chords, and look, both of those segments are the same measurement. Maybe that's what I was missing. Anyway, doesn't matter. Both of those segments are the same. So perpendicular here and the same measurements here, that means the chords are identical. I'm very confident we could prove this with similar triangles, but my mind is a blank right now. You're going to trust me though. Again, I'll say it again. If these segments that hit the chord and they hit it at a perpendicular angle, same here, and those segments are equal, then the chord CD must be equal to chord BE. They're asking us for CD, so that is also 9 units. Kind of bummed I couldn't remember that way of proving it, but okay. And this next problem is pretty similar. What is the length of the dotted line? It got cut off, of course. So this dashed line, it's pretty much the same thing, but in reverse. These chords are both 14. They're equal. And they are also perpendicular to this segment from the center to the chord, perpendicular here, perpendicular there. Just like these two were congruent, these two are also congruent. So that line segment of the dashed line is also 13.5 units. Sloppy. It's like these are the same rule, but one's in reverse. They give you different pieces of information. It's all about they must be perpendicular. So pay attention to that. Believe it or not, we're almost done. I'm going to let you do 7. I'm going to let you do 8. And I think actually we are done. Yeah. This is a short one. I'm going to put that back in case you needed to see it. Thought we had a few more. No, it's a very short lesson. Have a great day. That's it. So.